Hello friends, and welcome to Webronaq. Just this past March, WG21 officially shipped C++26 in London Croydon, the newest C++ standard in 3 years. It brings compile time reflection, contracts, and a further refined std format and std print story. So here is a question worth asking right now. If std format is so clean and modern, why should you still care about custom stream manipulators? The answer is that manipulators and std formats solve slightly different problems, and in many real codebases you need both. In this video, you will learn exactly what a manipulator is, how to write zero-argument in parameterized versions, and when to reach for one instead of std format. Let's start with the foundation. Alright, let's get the mental model right. A manipulator is just a function. It takes a stream reference and returns that same stream reference. That is the entire contract. The magic is that ostream already has a built-in overload of operator left shift that accepts a pointer to exactly that kind of function. So when you write count left shift endl, the compiler does not treat endl as data. It sees a function pointer, calls that overload, and ostream calls endl for you, passing itself in. Endl writes a new line and flushes the buffer, then returns the stream so the chain keeps going. That is the whole mechanism. Built-in ones like endl, hex, and flush all follow this same pattern. Your own manipulators can too, with no extra framework needed, at least when they take no arguments. Next, let's write one. Here is the interesting part. Writing a zero-argument manipulator is almost embarrassingly simple. You write a plain function that takes ostream by reference and returns it. Look at the USD manipulator on screen. It chains fixed and set precision of 2, writes a $, then returns the stream. That is all there is to it. At the call site on line 12, you write count left shift USD left shift price. The stream sees USD, recognizes it as a function pointer, matching that built-in overload, calls USD passing count in, and USD does its work. The variable price is 4.5, so after the manipulator sets fixed point mode with 2 decimal places and writes the $, price comes out as 4.50. Full output, $4.50. Clean, reusable, and 0 extra machinery required. Now let's add a parameter. Now, what if your manipulator needs an argument? Here is the problem. Operator left shift already matches a plain function pointer, but it has no way to carry extra data along. The solution is a helper struct. You bundle the parameter inside a struct, write a factory function that builds it, and then overload operator left shift for your struct. Look at the leading 0 example. The struct leading 0 holds one integer called n. The factory function leading 0 of n simply returns a leading 0 with n set. The operator left shift overload applies setfill of 0 and setw of n, then returns the stream. At the call site, leading 0 of 5 passed to operator left shift sets width to 5 with 0 fill, so the integer 42 comes out as 00042. This struct plus factory pattern is exactly how the standard library's own setw and setfill are built. Let's see where this really matters today. Here is where this becomes concrete in 2026. Visual Studio 2026 ships with MSVC Build Tools version 14.50, a long-term support release. In that toolchain, both iostream and std format coexist. When you target a new pipeline that uses std print, writing a std formatter specialization is the right move. It is stateless, composable, and works neatly with the format string syntax. But many production systems, especially logging libraries and file-based audit trails, still accept an ostream reference directly. If you pass a file stream to a third-party logging API, you cannot use std print there. You write to the stream the library gave you, and your custom manipulators work exactly as they always have. The USD and leading 0 manipulators you just built drop straight into that flow, no changes needed. Knowing both tools means you reach for the right one every time. Alright, let's bring it all together. A manipulator is just a function the stream calls for you. That single sentence is the whole mental model. When your manipulator needs no arguments, write a plain function taking ostream by reference and returning it. The stream's built-in operator left shift for function pointers does the rest. When you need to pass a value in, bundle it in a helper struct, write a factory function, and add one operator left shift overload. That is the full pattern, and it is exactly how the standard library built setw and setfill. Reach for a manipulator when your output target is an ostream API. Reach for std formatter when you are in the std format and std print world. Know both, and today's C++26 codebases hold no surprises. Thanks for watching, and I will see you in the next one.